On a tranquil evening in 1976, as the stars twinkled brightly across the night sky over Cambridge, whispering ancient secrets of the cosmos to anyone who would listen, the brilliant physicist Stephen Hawking sat quietly in his study, a room overflowing with towering stacks of books, scattered papers, and handwritten notes that chronicled his relentless pursuit of knowledge. The soft glow from his desk lamp cast gentle shadows across his immobile face, elongating them dramatically on the walls lined with equations and diagrams, creating an atmosphere of profound introspection amid the hush of the university town. Suddenly, deep within his stream of contemplative thoughts about the enigmatic nature of black holes, those mysterious regions of space where gravitational forces are so immensely powerful that they devour even light itself, causing everything to vanish into an infinite void, Hawking envisioned himself standing perilously close to the edge of a colossal black hole. He felt the icy cosmic winds whipping past him, carrying eerie whispers from the fabric of spacetime as it warped and bent under the hole's influence. In this vivid mental image, he held a thick, heavy book filled with intricate mathematical formulas, profound philosophical ideas, and groundbreaking theories, and with a deliberate motion, he tossed it gently toward the gaping maw of the black hole. The book hurtled forward, yanked inexorably by the tremendous pull, accelerating until it crossed the event horizon, the point of no return where familiar physical laws seemed to fracture and dissolve, and disappeared entirely from view, lost forever in the singularity's embrace. Drawing from the sharp reasoning rooted in Albert Einstein's general theory of relativity, which describes gravity as the curvature of spacetime, and the principles of quantum mechanics, which govern the behavior of particles at the smallest scales, Hawking concluded that black holes act as vast cosmic traps, enormous mouths yawning open to swallow anything that ventures too close, from tiny specks of interstellar dust to massive stars at the end of their life cycles, and even that imaginary book laden with human intellect. Every bit of information contained within the book, the carefully chosen words, the elegant equations, the layered meanings and insights, would be erased permanently, with no possibility of retrieval or escape back into the observable universe. Imagine the profound sense of loss, something that once existed with purpose and value, now dissolved into nothingness, as if it had never been created at all, leaving behind a chilling emptiness in the minds of observers who ponder such irreversible annihilation. This argument, at first glance, seemed straightforward and unremarkable, especially in the 1970s when many scientists were engrossed in other groundbreaking discoveries, such as the confirmation of quasars or advancements in particle physics, and black holes remained largely theoretical constructs, distant and abstract, discussed more in mathematical models than in observable reality. Yet, no one could have anticipated that this seemingly whimsical thought experiment, born from a moment of quiet reflection at his cluttered desk surrounded by the faint scent of old paper and ink, would ignite a subterranean storm of intellectual turmoil, sparking a decades-long debate that threatened to upend the very foundations of modern physics, principles meticulously built and trusted over centuries, from Isaac Newton's laws of motion and universal gravitation, which explain planetary orbits with precision, to Einstein's revolutionary insights into space, time, and energy, all encapsulated in formulas that predict everything from the trajectory of satellites to the fission of atoms in nuclear reactors. To truly grasp the man who launched this theoretical bombshell, one must delve deeper into the multifaceted personality of Stephen Hawking, viewing him not merely through the lens of a heroic figure triumphing over adversity, but as a complex individual brimming with vibrant quirks, unexpected depths, and a spark of irreverence. Most people recognize Hawking as the diminutive genius confined to a wheelchair, his body ravaged since the age of 21 by amyotrophic lateral sclerosis, progressive neurodegenerative disease that gradually stripped away his ability to move, speak, or even gesture, yet left his mind soaring freely to unravel the universe's greatest mysteries, from the Big Bang's explosive origins to the ultimate fate of stars. He became an enduring symbol of extraordinary resilience, his faint but determined smile inspiring millions worldwide through best-selling books like A Brief History of Time, which demystified complex concepts for the general public with accessible analogies and clear explanations, selling over 10 million copies and translating into dozens of languages. Iconic images of him, receiving thunderous applause at scientific conferences, his synthetic voice droning steadily through lectures on cosmology, evoke deep admiration, with audiences hanging on every electronically generated word amid the hum of projectors and the rustle of notebooks. However, this portrays only the public, heroic facade. To close colleagues at the University of Cambridge or collaborative institutes around the globe, Hawking revealed a strikingly different side, daring to the point of mischief, delighting in playful pranks, occasionally arrogant about his intellectual prowess, and unafraid to inject humor into the gravest discussions about the cosmos, lightening the mood with witty asides that could disarm even the most solemn gatherings. Picture a scene recounted in the memoirs of Sir Roger Penrose, Hawking's longtime friend and collaborator, who described him not just as an intellect of rare caliber but as a presence that commanded attention, perpetually in his grey wheelchair, his face nearly expressionless due to the illness, his sharp eyes gleaming behind thick glasses, and occasionally, a pale smile creeping across his lips. That smile was enigmatic, blending an almost angelic innocence that radiated warmth and profound wisdom, evoking a sense of comfort and enlightenment, with a devilish mischief that quickened pulses, thrilling interlocutors with its mystery while instilling a subtle chill, as if confronting a superior mind that held all answers yet chose to reveal them sparingly. The conference rooms where they met were often silent, broken only by the low buzz of computers or the turning of pages, until that smile erupted, shattering the formality and inviting laughter. Communicating with Hawking amplified this blend of discomfort and fascination. He spoke sparingly, especially as the disease advanced, his natural voice fading into prolonged silences that could stretch for minutes. Envision posing a question about quantum gravity in a tense room filled with expectant physicists. The air grows heavy, clocks ticking loudly, until just when attention wanes, Hawking responds with a terse, profoundly obscure phrase, punctuated by a teasing grin, implying, "You wouldn't understand anyway, I do." Colleagues likened conversing with him to consulting an ancient oracle, reverent, shrouded in enigma, requiring patience and humility, the solemnity occasionally pierced by his chuckling interjections that humanized the exchange. Hawking's audacity extended beyond theory into everyday life, leaving those around him in a perpetual state of alarm and exhilaration. During one outing with fellow physicists along the winding paths of the hilly countryside near Cambridge, where fresh grass scents mingled with birdsong and crisp air invigorated the group, they ascended a steep slope, jackets fluttering in the strong breeze. Hawking, leading in his wheelchair, paused at the crest, his eyes sparkling with that familiar impish gleam. Without hesitation, he released the brakes and propelled downward at full speed, wheels screeching on the gravel, wind roaring, scenery blurring like a high-speed chase in a thriller film. His companions panicked, shouting warnings, scrambling after him in vain, hearts pounding with dread of catastrophe. Yet at the bottom, Hawking awaited calmly, shoulders shaking with mirth, and quipped in his synthesized voice, "Any steeper hills around here? Let's give it another go." This shift from terror to relieved laughter encapsulated his adventurous spirit, unbound by physical constraints, reminding everyone that limitations were merely challenges to defy. The wheelchair itself, an inseparable emblem of Hawking's existence, evolved over time. Initially, while he could still vocalize faintly, it was a standard model accompanied by nurses monitoring his vital signs amid the beeps of medical equipment in hospitals or auditoriums, and interpreters to amplify his whispers. Later, as communication grew arduous, Intel engineers crafted custom software that converted text to the iconic monotonic electronic voice heard by millions in documentaries and talks. Input relied on the subtle twitch of his cheek muscle, the only movement he retained, detected by an infrared sensor on his glasses, each blink a heroic feat in the quiet struggle, producing just a few words per minute amid soft keyboard clicks. For major events, like television interviews exploring the origins of the universe or public speeches on time travel paradoxes, he pre-composed extensive scripts, delivering them seamlessly to rapt audiences in packed halls, culminating in resounding ovations that echoed his triumph over silence. Returning to the core idea that shook the scientific world, Hawking posited that anything plummeting into a black hole, from subatomic particles to entire galaxies, vanishes irretrievably beyond the event horizon, aligning with relativity's one-way barrier. But he pushed further, demonstrating via quantum mechanics that black holes evaporate over immense timescales, trillions upon trillions of years, through what became known as Hawking radiation, virtual particle pairs emerging from the vacuum near the horizon, one falling in while the other escapes, siphoning energy and causing the black hole to shrink, diminish, and ultimately dissipate like mist in sunlight. This evaporation not only erodes mass but eradicates all internal information, akin to burning a library where ashes scatter irretrievably. For physicists, this was outrageous and deeply unsettling, violating the conservation of information, a cornerstone principle stating that data, whether encoded in matter or energy, cannot be destroyed, only transformed, much like energy in a closed system. Either Hawking was mistaken, or centuries of physics from Newtonian mechanics to quantum field theory required radical overhaul, fueling heated debates in journals, conferences, and late-night seminars where voices rose over coffee-stained tables. Exacerbating the frustration, Hawking would flash his provocative smile post-presentation, challenging the establishment as if daring rebuttals. His proofs, grounded in rigorous mathematics involving complex integrals and field theories, left little room for counter-arguments, forcing the community to grapple with implications. The destruction of information posed a catastrophe. As black holes evaporate, the universe would progressively forget its own history, events and entities erased as though non-existent, yielding a sterile void. What exactly is information, and why does its preservation matter so profoundly? It transcends mere objects. Consider a glass of chilled water on an aged wooden table, condensation beading on the surface, visible details like coolness and clarity constitute information. Contrast with the song of a nightingale echoing through a lush forest, its melody exists intangibly in memory but propagates via sound waves, shared in conversation, etched in brains, evoking joy. A physical book holds data in ink and paper, weight, texture, aroma of aged pages, while printed words encode ideas, decipherable only with literacy. Currency shifts from paper to digital bits in bank servers, value intact amid confirmation tones. Einstein's equation E equals mc squared equates mass and energy yet conserves both. Further illustrations abound, a literature enthusiast randomly assembling letters from a scattered pile on the floor, clattering sounds filling the room, might wait until age 70 for 5 meaningful sentences, information arising from rare order amid chaos, quantified bustling by entropy as disorders measure. Atoms carry spin, charge, mass, detected in accelerator collisions with resonant hums. Information permeates reality, from concrete to abstract, mutable yet indestructible in form. One cannot fully obliterate it, incinerate a tone, ashes dissolve in oceans, data persists encoded in molecular arrangements, practically irretrievable amid crashing waves. The cosmos archives everything in spacetime's weave of matter and energy. Tying back to Hawking's claim, does information plunging into black holes perish upon evaporation? The tale unfolds complexly. In 2004, Hawking conceded error, proposing information leaks via radiation in scrambled form. Debates rage on, invigorated by string theory positing multidimensional vibrations, or holographic principles where a black hole's contents project onto its two-dimensional surface like a three-dimensional image from a flat hologram. Cutting-edge research from 2025 at the University of Cambridge suggests preservation through quantum wormholes, microscopic tunnels linking interiors to exteriors, even post-evaporation. The universe guards its enigmas jealously, but Hawking's dialogue endures vibrantly, with supercomputers simulating black hole dynamics in state-of-the-art labs, their fans whirring as new generations probe the paradox he unveiled.